Estimating roots. Sometimes you might encounter an imperfect root. So, for example, 25 and 36 are perfect squares, so we can figure out the square root of 25 and the square root of 36 very quickly. These are called perfect roots because they come from just a whole number squared. So what about the square root of 28? It's not perfect, but we can still estimate it. And this is a skill that we just want to develop in this unit so that you can quickly get a sense of what a value should be. So for example, well, let's take a look at the square root of 28 by looking at the perfect roots around it. So we know that 5 squared gives 25, which means that the square root of 25 equals 5. And we know that the square of 6, I'm leaving some space in the middle here on purpose. We know that the square of 6 is 36, which means that the square root of 36 is 6. Well, that means that the square root of 28 has to be somewhere in between these other two square roots. So it has to be somewhere between 5 and 6. So where is it going to be? Well, it's because 28 is closer to 25 than it is to 36, it's probably going to be somewhere over here, which means that we're looking at a number that's 5 point something, and the decimal value has to keep it closer to 5 than it is to 6. So a reasonable estimate, well, maybe 5.1 or 5.2. I'm just going to go with 5.2. So there's my estimate of the square root of 28. We can check this very quickly by checking in our calculator. And if we check it in our calculator, the square root of 28 is actually equal to 5.29150 ... carried on, unrepeating decimals. So my estimate wasn't perfect. I would have been more correct if I had estimated 5.3. But in this section, all you have to do is be able to explain your estimate and get close, which means being off by probably less than within a couple of decimal places, let's say. So 5.2 was a low estimate, 5.3 would have been better, but 5.4 also would have been a reasonable estimate. With any of these problems, the key is that you just need to explain your reasoning for any estimation. You can't just write a number down with no justification. You have to justify to us the thinking that's going on for your estimation. So here's an example of how I would show that. If I wanted to estimate the cubed root of -99, I would start by finding some perfect cubes nearby, like -125. The cubed root of -125 is equal to -5. And the cubed root of -64 is equal to -4. So the cubed root of -99 has to be somewhere between those two values. And where is -99 compared to -125 and -64? It seems pretty close to the middle to me. So this is about -100, which means that it's about 26 away from 125, and 99 is, I guess about 46 away from 64. So really like a little, not 46, 45 away from 64. So it looks like it's closer to this end of things, but it's, reasonably close to the middle. So I think that in that case, I'm between -5 and -4, which means I'm -4 point something and closer to -5, so I'm going to go with -4.6. And once you've explained your estimation, you can check it in your calculator. And when I check in my calculator, I get that it's -4.626 ... So I was accurate to 1 decimal place. And that's the accuracy, that's the amount of accuracy we hope to see you estimating to, just 1 decimal place.